Hello everyone, we have this question here coming from coordinate geometry. This is additional mathematics. The question reads, in the diagram below, ABCD is a trapezium with A, these are the coordinates for A, and C, these are the coordinates for C. The point B lie on the y-axis and angle DAB equals to 90 degrees. So this is the diagram given. So the question said find the equation of line AB. Find the equation of line AB. Okay, so start. So A, B. The first thing here, we need to know the coordinates for AB, and the coordinates for A we have been given it's 4, 1. And for B, we also have, which will be 0, 5. Here, we know that the x-axis in y-axis it's 0. So the coordinates for B here will be, for x will be 0, and for y to be 5. This is how I came up with this 0. So from here, we need to find the gradients. So say gradient equals to y2 minus y1 over x2 minus x1. So from here, this I'll call it my x1, this I'll call it my x2, this will be my y1, this will be my y2. So here is just to substitute. So my y2 here, my y2 it's 5 minus my y1 it's 1, then my x2 it's 0 minus my x1 it's 4. So I have 5 minus 1 to give me 4 over 0 minus 4 to give me negative 4. So here you have negative 4 into 4 to give me negative 1. So this is the gradient for AB. So we need to find now the equation of line AB. So just here, pick this point for B. So to write the equation, say y minus y1 equals to m open bracket x minus x1 here. And the coordinates that we are using is for B, which is 0, 5, and this one will be our x1, this will be our y1. So here, say y minus our y1 it's 5 equals to our gradient it's negative 1 open brackets x there, and our xy1 it's 0 here. So have y minus 5 equals to, here we have negative x. We are going to multiply here negative 1 multiplied by x to give us negative x. Then negative 1 multiplied by 0 there, it will be just 0. And from here we'll have y equals to negative x plus 5. Here 5 it was negative. When it goes the other side, it becomes positive. So this is the equation for line AB. Then for B, find the equation of line AD. Line AD. So here we need to understand something here. So line AD, there's this angle that is formed here, which is 90 degrees. So in short here, it's AD, they form a 90 degree with AB here. So what it means here, in order for us to find the gradient first for AD, this is perpendicular. So we use this formula, m1 multiplied by m2 equals to -1, where our line AB, we know it's the gradient for line AB, we know it's -1. So this is our first gradient, and in order for us to come up with this second gradient, we use this formula. So here we'll say our m1, it's -1, the gradient that we found for AB, multiplied by m2 equals to -1. So here we'll divide both sides by -1, even there by -1. So we'll have m2 equals to positive. Then from here we'll use the coordinates for A, which is 4, 1. So we'll write the equation y minus y1 equals to m open brackets x minus x1. So here we'll have, this will be our x1, this will be our y1. So here we'll have y minus 1 here equals to our gradient, it's 1 open brackets x minus 4 there. So here we have y minus 1 equals to, we multiply here 1 by x to give us x, 1 multiplied by -4, it will be -4. So here we have y equals to -1 here, y minus 1 equals to x minus 4. I've just repeated the same thing. So here I'll say y equals to x minus 4. Then this -1, when it's got the other side, it becomes positive. So here I have y equals to x minus 3. So here you just subtract and get the sign of the bigger number. So this will be our equation for line A, D. So the last one said find the coordinates of D. Find the coordinates of D. Find the coordinates of D. So now we are looking for these coordinates of D. So in order for us to find the coordinates for D, we need to understand something here. AB and DC, these are parallel. They are parallel lines. So that means AB and DC, they have the same gradients. So we need first to find the equation for DC. So since we know that AB and DC, they are parallel lines, they have the same gradients. So we'll say the gradients for line CD should be equal to the gradient of line AB, and we know that the gradient for AB it's -1. So now we need to find the line for CD, the equation of CD. So how can we find that? We use the coordinates for C. So here we write the coordinates for C. It's one that we are going to use because line CD passes through the coordinates for C. So the coordinates for C here, it's 4, 5. So write the equation, which is y minus y1 equals to m open brackets x minus x1. So this is our x1, this is our y1. So here you have y minus our y1 here, it's 5 equals to the gradient, it's -1 here, then x minus 4 there. So here we'll say y minus 5 equals to, so we will multiply -1 by x, we will get negative x. -1 multiplied by -4, it will be positive 4. So here you have y equals to negative x plus 4 plus 5. Since here 5 it was negative, when it goes to the other side it becomes positive. So I have y equals to negative x plus 4 plus 5, it's 9. So this is the equation for line CD. This is the equation for line CD. So in order for us to find the coordinates for D, we need to find the intersection of line AD and DC or CD. So we know that the equation for line CD, it's equals to y equals to negative x plus 9, and the line for AD, it's y equals to x minus 3. So we need to find the intersection of these two equations. So what we are going to do here, we'll just equate these two equations. So we'll say x minus 3 equals to negative x plus 9. So in short here, where there is y here, we are going to put that one like this. So from here, let's solve for the values of x. So have x here to come the other side, it will be positive. X equals to 9 plus 3. 3 here it was negative. When it goes to the other side it becomes positive. So have x plus x here, we'll get 2x equals to 9 plus 3. We'll have that's 12. Then we divide both sides by 2, even there by 2. So this and this cancel, so have x equals to 2 into 12, that is 6. So in order for us to find the y value, we just choose any equation, then and where there's x we just put 6. So I'll pick this one. So have y equals to x minus 3. So have y equals to, where there's x, let us put 6 minus 3. So here you have y equals to positive 3, and therefore the coordinates for D will be 6, 3, like this. This is how you go about this question. Thank you very much for watching. Don't forget to comment, like, and share.